So the question is, what are some of the recent advancements or breakthroughs in your respective fields that you find particularly promising? And, well, recent, let's say 2020 till now. So we'll start off with Raphael. You're smiling and you look like you're champing.
Oh, I was thinking, what is my field, right? Because we're very much in the last mile of applying the wonderful stuff that y'all come up with and making it useful on the ground. But so I'm extraordinarily excited about research like what Bert is doing, and feel like as Guillaume was saying, we're also starting to see some convergence on different ways to get to the same, at least to the same shape of answers, and in some cases even to the same results. So, like, one example of this is work that Chris Fields, Carl, and others have been doing on the quantum. Basically explaining quantum information theory and how it relates to the free energy principle, looking at the free energy principle as the classical limit of quantum information theory. And I don't pretend to understand all of it, but as somebody who's coming from a quantum physics background, just being alive to see this kind of convergence happening, which, as Guillaume said, we've been at this business of like post-classical. What the hell is going on for over a century now? And it's nice to be at a time where again we're starting to talk less past each other. And that's from a theoretical perspective. From a practical perspective, I think just finding that we have all the building blocks to create fast, interpretable, reliable, and aligned decision-making systems, which includes AI systems, autonomous systems that have all those characteristics. And that it turns out that all the things that the reinforcement learning and deep neural networks people thought were very hard or impossible are sort of in the realm of what we can do, looking at things from an active inference lens, and vice versa. A lot of things that active inference models have incorporated so far. It turns out if you toss in a neural network approximator here, borrow some other, massively parallel computation techniques, it also becomes feasible. So it's converging.
Yeah, for me, what's remarkable is that there's so many domains of what we thought was exclusively human or would be exclusively human for decades, that in just the past couple of years, robots or computers seem to be just as good, if not exceeding us. And I don't know if that's promising or worrisome. But anyhow, Carl, please, if you don't mind answering the question, and then we'll go Anna, then Bert, and then Dumas.
Actually, just reflecting upon your one of your observations, I think it's very difficult to identify one thing. In a sense, what is impressive is the diversity of advances and applications. And I just say that because that's what I was thinking, over the past 6 hours, just listening to, amazing presentation after presentation, and just, noting how diverse, and yet there's this common thread, this common commitment, basically sating our curiosity and using the tools that naturalize that kind of sense-making, curious behavior and communication that inherit from sort of either maths or category theory, or as Ralph notes now, quantum information theory. But just to pick up on a couple of things which are relevant to this conversation. So the work with Chris Fields, it sounds lovely and exciting to bring quantum mechanics into active inference, but that's not the move that I think Chris is really wanting to champion. The move, I think, is something that we've all been addressing in one way or another, which is leveraging the scale-free aspects of this principled approach to self-organization, and hopefully self-organization to some kind of generalized synchrony. So that's where the quantum information theory gets into the game. It is scale free, and indeed he will go further and say it's completely background free, and everything is constructed. It's just so I think that's a lovely move, because once you've gone scale free, you then start to ask deep questions about how you couple one scale to another scale. And in a sense, ecosystems is just that. How do the denizens of an ecosystem, how is it constituted? How is it co-constructed? What is the structure of it? These are all questions about how one scale links to another scale. So I think there have been lots of advances in that direction in many, many different fronts. And you can read that either in terms of coupling different sort of spatial or spatial scales, but probably more importantly, sort of temporal scales. And you see that, wherever you look. You'll just come back to what do you mean by a narrative? It is exactly, I think, as I said, it's just a plan. It's just a story. But notice the story has a temporal aspect to it. I have narratives about being a good person, being a good father, being a good scientist. I also have narratives about, I want my cup of coffee, or I have to go look after if I don't, but Ralph has to go look after the child. So, we've all got narratives at very, very different timescales. And of course, if you're, just going back to Bert's example of, I'm an autonomous vehicle and I'm sentient and we're 5 years into the future and I have to drive around the roundabout. What temporal scale and what kind of temporal coarse graining to define the narrative necessary with narratives would be appropriate for that kind of situation, and the ensuing planning. So a short answer to your question, I think there have been many, many advances. They have, I think what they've had in common is basically transcending either different domains, but in particular different scales of application. I also agree with the notion, another, I think, important and pragmatic advance is something that Bert mentioned, which is the democratization of this technology. And I think Ralph also hinted at, this is the time you start using this for the common good. So I think, things like RxInfer and PyMDP, and I didn't know about the Gaia project, but it sounds as though there's been great advances there as well. So this kind of democratization, I think, is really important. This sort of socialization where everybody can play and start to sort of not to talk past each other. I think that's a very important advance.
And did you say the word scale invariance or scale independence?
I say scale invariant. I actually said scale free, and I shouldn't have done that. I meant I said scale free. So the idea that you can apply exactly the same mechanics and literally, for example, say from Bert's perspective, the same kind of message passing at different space-time scales, or at different levels in a hierarchical model. So I've actually got a question for Bert in terms of reactive message passing, because reactive means that you don't have to prescribe the scheduling, but you in addressing the problems or the issues that are entailed by having to specify the scheduling of talking or of message passing, you're bound to deal with time, and in a scale invariant context or nested scales, for example, you have to deal with the separation of temporal scales. So I think there's going to be a very important generic question, which technically Bert will have been thinking about furiously for the past few years, but I think implicitly we're all going to have to be addressing soon, which is the how do you put the timing of your messages when you make a move, or when you listen to a patient, or when you actually pass a message on a factograph. How are we going to be able to put the separation of time scales into the architecture in a way that speaks to this scale invariance. The GEAR project, for example, how do you integrate live feed from traffic flow sensors with fluctuations in the climate? This kind of data comes at very, very different temporal scales, and yet has to be assimilated and modeled in a way that is also, I think, has to pay due courtesy to that separation of temporal scales.
If you enjoyed that clip, then the full podcast is out right now. You can click around here. Enjoy. Subscribe to Theories of Everything to get notified of upcoming podcasts, as there are new full-length podcasts every week on the topics of mathematics, physics, consciousness, free will, and AI.